All right, here, this is multiplication of exponents. So what we're going to do this unit is discuss the properties of exponents. And you'll see here that this first property is called what is called the product of powers property. So what that means is, what do we do when we multiply things together that have the same base? So let's look at and do a little review here. When looking at this particular problem here, this little number up here, which I'm sure most of you know, this little number is called an exponent. But what many of you might not remember is that this is the exponent, and this, the number that's below it, is called the base. Okay, this is called a base. So you can see here, you're multiplying two things that have the same base. So what do we do with our exponents? Well, in multiplications, the product of a power property says that when multiplying things of the same base, you add the exponents. So you can see here how the exponents just get simply added. And so instead of 3 to the second and 3 to the seventh, you now have 3 to the ninth power. So how that looks in an actual problem, so we go over here to number 1, okay, 4. When we do this, when there are no exponents, we assume that the exponents are going to be 1. So when we multiply these, you get 4 to the, and adding up all the exponents, you get 3. Now with this particular problem, you can actually calculate the value of this. 4 to the third, we can actually do 4 to the third, which is 4 times 4 times 4, which is 64. Okay. Now let's look at one with variables. Same thing with variables. No exponent. We assume that it's going to be a 1. 1, 1, 1. So this becomes n to the, and then we add up all the exponents and we get 4. Now that one we can't solve, obviously, because it's a variable. So that's all we could do. So just going through real quick here. Okay, again, this is multiplication, same basis, add the exponents, 2 to the 19th. Now, I'm not going to calculate 2 to the 19th, but you can do that. It's a really high number. 4, again, don't forget that the ones that don't have exponents have a 1. This is actually x to the 6th. Okay. Now, I'm going to have you go ahead and try 1, 3, and 5, okay, right here, right here, right here, on your own. I'm going to pause the video so you can do your work. Okay, so you should have gotten for number 1, y to the 5th, and then number 3, x to the 8th, and then 5 is a little tricky, but we do go in alphabetical order, so work with your x's first. So I have x to the 5th, and then since everything's being multiplied, the y just gets tacked on. There's nothing to combine it with. Okay. Now, what if we have numbers in front? So as we look at number 2 here, you'll see that we have numbers in front. Well, if this is the exponent and this is the base, the number that is in front of the base here is called a coefficient. Coefficients get multiplied, because this is multiplication, they get multiplied just like any other number. So we take 3 times 2, and that gives us 6. So whatever the operation is, the coefficients will do it. If it's division, they get divided. If it's multiplication, they get multiplied. So they don't change how you do those. 3 times 2 is 6. The only thing that has changed is how we deal with these exponents, which means we add them. It's multiplication, so we add them. 2 plus 3 is 5. And then finally, number 4, again, we always go in alphabetical order. So starting with our A's, count them up. You got 2 here and 1 there. That's 3. Then we move on to B's. You have 1 there. That's it. And then C's, 3 there, 2 there. That's 5. All right, that is product of a power. There's some more practice problems throughout here. why don't you go ahead and try number 6 there on your own, and then I'll show you the answer. Okay, so there's number 6, negative 6x to the 4th. We're going to move down to number 8 down below here. One thing to understand is always look for those coefficients. Even though you can see here in this problem, it may not look like there is coefficients, but there is actually a coefficient right here. And if you guess that it's negative 1, then you are right. There is a negative 1 there. So that negative 1 has nothing to multiply to, so the negative 1 is just going to come down. And then you proceed within your exponents in alphabetical order. So x to the, you have 1 there, 3 there, that's 4. Y 2 and 1 is 3. Okay, so now we're going to work with number 7. So let's shift over here. Number 7, again, be careful with these coefficients. Okay, coefficients, there's actually another coefficient right there. It's another negative 1. So 4 times negative 1 is negative 4. Remember, coefficients, since this is multiplication, the coefficients don't change what we're doing. It's multiplication, so they get multiplied. Then you work in alphabetical order. There are 3 x's, there are 2 y's, and you have a z to the 2nd. Now, 9 is a little bit different. It's another way of doing this multiplication. Here you have a set of parentheses with something on the outside. And what we've done in the past is you would distribute. And the same case goes for these types of problems. So when I distribute, you're going to first distribute this times this. That's what you always do in distribution. You multiply times the first term. So same thing that we did. If you look over here, it's the same thing as number 6. Okay, so you're still going to multiply your coefficients. 3 times 2 is 6, and there's an x squared and x to the 1, so it's x3. Then we move on to the next term. So 3 times negative 4 is negative 12, and there's x1 and x1 make x2. Then we go to our final term. 3 times 3x is positive 9x. Now, common mistake here is students think that they can add all these together. They can combine all of them. Remember when you're adding and subtracting that they have to have not only the same letter. They clearly all are x's, but since they have different exponents, they cannot be added together. They are not like terms. Therefore, that is your answer. Go ahead and try number 10, and we'll give you the answer. So there is your answer. Distributing to each piece, you have, notice how you have 1, 2, 3, 4, so I should have 1, 2, 3, 4 terms. And you're done. Okay, move on. We're going to take it up a notch here. Division is sort of similar. We just did multiplication, so you can probably guess what you're going to do here. With multiplication, we added our exponents. So with division, you can see here that you have 3 to the 7th or 3 to the 5th. They simply just subtracted the exponents to get their answer. Now, there's only one trick here. Okay, you can't just go subtracting, just whatever. So you have to understand that you cannot in any way have negative exponents as your answer. So if you were to do 15 minus 9, that would be a positive answer and everything's okay. But you'll notice in B that if I did 7 minus 9, if I did 7 minus 9 here, I would get a negative answer. So what do? So the trick here is to subtract from the bigger side. So if you notice here that the 15 is a bigger exponent than the 9. Therefore, I know that my x is going to remain on the top, and then I subtract from the top. So 15 minus 9 is going to be 6. Now, do we need a bottom of the fraction? Anymore, the bottom of the fraction, we don't need a bottom of the fraction, therefore this is just your answer. You're going to find here in B that though we don't need a bottom of the fraction, we always do need a top of the fraction. So, again, here, notice that the bottom number is bigger. Since the bottom exponent is bigger, the 8 is going to go on the bottom, and then we subtract from the bottom. Instead of doing 7 minus 9, which would give us a negative number, we're going to do 9 minus 7, which gives us a positive 2. Now, in this case, in letter A, we did not need a bottom, but we always need a top. And if there is no top, we just replace it with a 1. Now, this one you can actually simplify. I do know what 8 squared is. It's 64. And that is your answer. Moving on here, again, division, subtract your exponents, but subtract to the bigger side. Since the y is bigger on top, the y is going to go on top. 6 minus 0 is 6. Don't need a bottom. If you would like to, you can put a fraction and put a 1 on the bottom, but that doesn't change the answer at all. Okay. So that's your answer, or you could just put y to the 6th. Okay. Let's look at some of these example questions. Here on number 1, the 2 is bigger on top, so the 2 is going to go on top. 8 minus 3, 5. Now this one, again, you know the answer. You can actually calculate it. 2 to the 5th is 32. Okay. Go down here to number 2. One thing I want you to take notice here is these can't actually be subtracted from one another, because if you notice, they have to have the same, in order to combine like terms, in order to do this, they have to have the same base. We talked about this before, but here's an example where the bases are not the same, therefore these cannot combine. Now I can simplify them. I do know what 5 squared is, that's 25, and I do know what 7 squared is, that's 49, but that's as far as you can go with that problem. Over here to 3. Negative numbers always give students a lot of trouble. You have to really think here which exponent is actually bigger. Now if you guess that the negative 2 is actually the bigger exponent, then you're correct. Negative 2 is actually larger than negative 5. Therefore, my number is going to go on top, and I subtract from the top. But be careful. Okay, a lot of students think that this is simply just negative 2 minus 5. Okay, completely forgetting the fact that because this is division, you're subtracting anyways. Since this is negative 2 and a negative 5, you're subtracting a negative. This is not negative 2 minus 5. It's negative 2 minus negative 5. So if I were to write this out, negative 2 minus negative 5, this clearly changes to a positive. So negative 2 plus 5 is 3. So be careful with those negatives. It always tricks people when they're doing this. Hey, when you're subtracting something that is already negative, it changes it to a positive and you add. 5 to the 3rd is 125. Okay. Number 4. Now what happens if both of your exponents are the same? Well, you can still subtract them. It just doesn't really matter where you write the answer, top or bottom, it doesn't really matter. Most people just put it on the top. Negative 4, 8 minus 8 is 0. Now, we haven't learned on what to do with negative exponents yet. With 0 exponents yet. So I'm going to ask you just to leave it like this for now. We'll learn next week what to do when we have an exponent of 0. Okay, let's look at number 5. 5 is when multiplying to a fraction, but we've learned last semester that anytime you're multiplying to a fraction, you multiply times the top, then divide by the bottom. So we're going to multiply times the top. Z to the 7th times 1 is simply just Z to the 7th, with Z to the 8th on bottom. And now we can divide by the bottom. Understanding that the z is bigger on the bottom, the z will go on the bottom. 8 minus 7 is 1. Since I have no top, I replace it with a 1, and I'm done. Okay. Number 6, sometimes you have multi-step. Sometimes you have to do several things first. Like, for example, in this problem, okay, I probably should take care of this piece first. Okay, since this is multiplication, if you remember from before, multiplication tells me that I add the exponents. So on the bottom here, I have x to the negative fifth and x to the negative fourth. I add them. Negative 5 plus negative 4 is x to the negative ninth. On the top, I have x to the negative eighth, and then I can now divide. The negative 8 is actually a bigger number, so the x is going to go on top. Negative 8 minus, this is not negative 8 minus 9, it's negative 8 minus negative 9, meaning I add, giving me a 1. Okay. To finish this off, I'm going to have you just try number 10 on your own, and then I'll give you the answer. And so here we go. Here's your answer. Notice how I completed the top here, okay, and added my exponents to give me m to the sixth. M to the 7th is on the bottom. I can now divide, meaning I subtract my exponents to the bigger side. So the bigger side is on the bottom. The m stays on the bottom, and I subtract 7 minus 6, which is 1. Since I don't have a top, the 1 goes on top, and that is my final answer. If you have any questions, please feel free to ask. You can message me on Canvas or come by during Academic Lab. Thank you very much.